Hello again and welcome back. I believe this is our final lesson. If it's not, I'm sorry. If it is, well, I hope you guys enjoy your summer and I hope you guys work hard and get the last few assignments done. Sorry I can't say bye to you in person. I really do miss you guys. All right, let's dive into 6.10, problem solving with volume. This is just basically applications of volume. So in this case, it's all stuff that you've already learned, but we're just applying it to real life scenarios. Our first example might not be used very often, but it's just showing that you have the ability to do so. The NBA uses basketballs with a radius of 12.296 centimeters. The WNBA uses basketballs of radius with a radius of 11.6 centimeters. First thing I want you to do is determine the difference between the volume of both. So first thing is we're going to do volume of NBA. And I'm going to do this in red, and then I'll switch over to blue or green. And the formula is 4 pi r cubed, just like we learned last lesson, all over 3. And we just sub in the r value. So we got 4 pi times 12.296 cubed all over 3. Use our calculator, and you should get 7,787.2 centimeters cubed. Okay, I'm going to switch over to green now. Red for that, of course, for the NBA. And where's my mouse? There it is. Let's use blue. I like blue. Blue for WNBA, so we see where I'm getting these numbers from. So the volume of the WNBA is 4 pi times 11.6 cubed all over 3. I didn't rewrite the formula because we had already just rewritten the formula in the first part of this. So let's just keep moving on. And you should get 6,538.3 centimeters cubed. Okay. Finally, we're going to figure out the difference between them. So volume, we'll say it's volume diff for difference, and we just subtract the two. So 7,787.2 subtract 6,538.3, and you should get 1,248.9 centimeters cubed. And because it's a word problem, we use therefore. Therefore, the difference, or diff for short, is 1,248.9 centimeters cubed. Next, I ask by what percent is the men's ball larger than the women's ball? So the NBA being larger than the WNBA, we just use our percent difference. And to calculate your difference in percent, you just put your difference over the volume of WNBA, and then multiply it by 100. So your difference over the smaller of the two totals, and in this case, the WNBA has a smaller ball, so it would be in the denominator or the bottom of this fraction. So then you just plug in the numbers now. 1,248.9 divided by 6,538.3 times 100, and that is equal to 19%. So therefore, the NBA ball is 19% larger. All right, let's go on to the next page. In this example, it's not a word problem, but it is a bit of an algebra problem because I need you to determine the height of the cone. And the volume of the cone is given. It's right here. Oh, so that's a little tricky. Well, it's actually not that bad. It's just, it looks tough because you guys haven't seen a question like this yet. And the way you do this is you actually just set up your volume of a cone. So you might have to go back and double check this, but it's just pi r squared times h all over 3. And that's your volume of a cone. And the only thing that you do, the only thing that you do now is you plug in your volume of a cone and solve for h. So you guys have actually done stuff like this before in our algebra unit. So pi, we know what r is because it's given to us. So we plug in our r squared, which is 8. So it'll be 8 squared times h. And all that over 3. Well, to get rid of the 3 in the denominator, because that's what we got to do first, is we got to get rid of the denominator. We're going to multiply both sides by 3. So we'll have 1,139 times 3. Because when we get rid of the denominator, we multiply both sides by 3. And it cancels that out. And we're stuck with this now. Okay, next step would be to get rid of the exponent next to the 8. That's going to make our lives a little bit easier. 8 squared is going to be 64. So I'm going to keep this like this because I want to do all my calculations at the very end here. Times 64 times h. And you remember what we would do whenever we multiplied something by x and we were trying to solve for x, we would divide by that. So in this case here, I'm going to underline it in red just so that you can see what I'm about to do. Whatever I just underlined in red, I'm going to divide both sides by, or the other side by that, and then I'll get rid of it. So then I'll have h equals this number. So let me just, I'm going to switch back and forth between my colors, so just bear with me. 1,139 times 3 all over what I underlined in red. So I'll have pi times 64. And then that's going to equal h. So now I can actually do this calculation. You can do a multiplication and divide a decimal number by a decimal number, or you could plug it all into your calculator. You might have to just put it in brackets though, so put this in brackets down here. So when you're dividing, it'll actually divide it properly. So it'll be 1,139 times 3 divided by bracket pi times 64 end bracket, and that should work. And that'll give you h. If you got 17, you are correct. It's 17 centimeters is equal to h. And that's all there is to it. All right, let's move on to the next question. Yes, this question with the balloon. It's a little bit weird to think about. Let me, get my black pen here. Okay. The way you think about this question, because you guys haven't seen this before, it is a little confusing, is there's really a sphere here that's separated by this long tube, this long cylinder. So really, you have a sphere and a cylinder. The sphere is basically cut in half, placed on both sides of a cylinder, and that's how you calculate the volume. So you're just going to calculate the volume of a sphere and calculate the volume of a cylinder. And that's all there really is to it. Before we really dive into it, though, we need to figure out what R is, because we're given what D is. Well, R is going to equal 7 over 2, which is 3.5. Okay. So now we know R is equal to 3.5. We can move forward. Let's start with our volume of a sphere. Volume of a sphere is 4 pi r cubed all over 3. And we're just going to sub in our r value. So we got pi times 3.5 cubed all over 3. And you should have 179.6 centimeters cubed. So that's our volume of our sphere. Next, we'll do volume of our cylinder, which volume of a cylinder is pi r squared times h. Sorry, my r looks a little off there. There we go. So pi r squared times h, we sub in our r value, which is 3.5. And the height of our cylinder was given in our image here. It's 12. So we just multiply it by 12. Oh, I forgot my squared symbol. Yeah, don't forget that, because you do need to square your 3.5. So 3.5 squared times pi times 12, that should give us 461.8 centimeters cubed. Now this is very, very similar to composite area, except now it's like composite volume. We have two separate shapes that we added together. So to figure out our total volume, our volume total, it's going to be our first volume plus our second volume. Which is just 641.4 centimeters cubed. Therefore, the volume of the balloon, sorry, balloon has two O's, is 641.4 centimeters cubed. All right, that is the end of that lesson. I don't think I have any more lessons for you, so I'm just going to sign off for the last time. If you have any questions, feel free to ask. You can always reach out via email. Even after this class is over, feel free to reach out in the Thames Valley email if you ever want to just touch base. Yeah, all the best. Get your work done. Enjoy your summer. And I hope to hear from you guys soon. All right.